Bismillahirrahmanirrahim. In this video, I'll be primarily solving practice problem 16.1 and 16.2, which is part of the application of Laplace transform and circuit element models. So let's start with the practice problem 16.1. Here we have to determine the output voltage V0t, and we are assuming that the initial voltage or current is 0. The technique that we need to follow is that first of all we convert the time domain circuit into Laplace domain or S domain. We solve the circuit and then we revert back into time domain by taking inverse Laplace transform. So for conversion into S domain, we follow these formulas, Laplace formulas. 1H inductor is written as SL, so we have 1 Henry, so it will just become S. The capacitor is also written as 1 over SC. Here C is 1 over 4, so it will become 4 over S. And so our circuit will become like this. The capacitor is now 4 over S. The current will now become 10 over S, and inductor is S. So this circuit we have to solve for V0S. Okay, so we are primarily interested in this current I2. So if we know I2, we can multiply it by 4 to get the V0S or the V output. So this current I2 can be found from the CDR. You know, this current is dividing into two paths, right and left. We are interested into the right path. So the formula, I hope you remember, that the total current divided by total impedance. So total impedance is this plus this plus this. So 4S, 4 divided by S plus 4, and then multiply by opposite arm. So we are interested in this arm, so multiply by 4 over S. So this is how by CDR we find out I2, and if you follow the steps, you can easily find the final value, which is 40 divided by S plus S into S. 40 divided by S into S plus 2 whole square. And now we multiply it by 4 to get the output voltage. So our output voltage in S domain is like this. Now to find this voltage into time domain, we have to take help of the partial fraction. So let's see that how we can divide. Okay, so since there are one term and this is a whole square term, so this is also considered two terms, one at a time. So first will be A divided by S, the second term will be B divided by this whole square term, and the third will be C divided by this term without this square. And now by residue method we will find the values. So residue method, I hope you recall how to do it. We multiply by the denominator. So A is equal to S, the denominator, multiplied by V0, and V0 we know this was what we had calculated. So S multiplied by this, and the limit is from here. We put this term equal to 0, so S is equal to 0. And so step by step solving, we find A to be 40. Now same technique for B. So B, now the denominator is S plus 2 square, so S plus 2 square multiplied by V0, this is V0, simplifying we get this, and the limit now in this case is this S plus 2 is equal to 0, that means S is equal to minus 2. So we put this limit, and the final value of B is minus 80. But for the third term there is a different technique that we have to keep in mind, that we differentiate this term to get the third term. Okay, so C will be d by ds of this, putting in the values, and this is the simplified form. And now I hope you recall the differential of the fraction terms. So by differentiating we get this minus 160 divided by s square. Putting in the limit, we get the value to be minus 40. So now we have got the three values. So V naught S, we had this formula, putting in the three values. This is what we are getting, and now we are in a position to take the inverse Laplace transform. We'll use these formulas. Okay, so inverse Laplace transform of each term. So 40 over S can be written as 40 ut from here, and similarly minus 80 divided by S plus 2 whole square, we'll use this formula. So T80, so minus 80 t e raised to the power minus 2t ut, and the third one is easy, it is minus 40 e raised to the power minus 2 using this formula ut. So this is the answer, and if you want it to be more neat, you take common 40 and take common ut. So this is how the answer has been written in the book. Okay, let's go to the practice problem 16.2. This is the circuit. Here also we have to find V naught t. This is being multiplied by ut. That means that the voltage is 0, because ut is 0 for t less than 0. So voltage is 0 for t less than 0, and therefore the initial current through the inductor will be 0. So IL is 0. And now we are let's convert it into the Laplace domain or S domain. We'll use these formulas for ut and 2h. Okay, so this will become our circuit. 75 e raised to the power minus 2 t will become 75 divided by s plus 2 using this formula. And similarly, the inductor 2 Henry will become 2s. We are taking these two currents, I1 and I2. We are primarily interested in I2 current, because I2 multiplied by 2 will get this voltage. So let's solve both the loops. So loop 1, we take the KVL equation in this loop. So this is the loop 1 equation, and I'm using my handwritten notes for this now. You can follow step by step. Multiply by s plus 2, we get this term, and keep simplifying. Further simplifying, same terms we have put together, terms for I1 and I2. Okay, then we move to loop number 2. So loop number 2 equation is 2s I2 minus I1, so I2 minus I1 plus 2I2, and from here we'll simplify and find the value of I1. So this is what is our equation number 2. Now I'll put value of I1 from here into equation number 1 that we got. So this is the equation number 1 we had. Now I'll put the value of I1 here. So we get everything in terms of I2. And why we are interested in I2? Because as I mentioned, that if you know I2, multiply it by 2, we get the output voltage. Okay, so here we have replaced I1 with this value. Okay, so we are here, and now we can solve step by step. You can pause the video and see how I have done. All the steps you can follow. And finally we got I2 in this form, and now multiplied by 2 we get V naught. So this is the value of V naught, and now we have to factorize this to take the inverse Laplace transform. So let's see, we were here, we factorize the denominator. So this is how I have done it. Take common and simplifying, you get this value. You dividing this 150 by 3. So this is the value, and now we are ready to, we have two factors in the denominator, so we'll now use the partial fraction method. So this can be written as a plus b terms, and now we'll use the residue method to find the value of a and b. So a will be v naught multiplied by s plus 2, and the limit will be s is equal to minus 2. From here we put s plus 2 is equal to 0, so s will be minus 2, and simplifying, putting the value, this is the final value of a is equal to 60. And same way for b, same technique exactly. So b is minus 10, and so our final value will be v0 for a, we are writing 60, and for b we are writing minus 10. And now we are in a position to take inverse Laplace transform. So from here we'll get 60 e raised to the power minus 2 tut from here, and this one will be minus 10 e raised to the power minus t over 3 ut, and this is the answer. And the book has just taken ut common to make it look neat. So this is the final answer. So I hope this gives you an understanding as to how we can solve this type of problem. If you think this has been beneficial, please share it with the friends, subscribe my channel, let others know about the channel. Thank you.